What if there was a way to see the northern lights or aurora in a place where it's never seen before, like Indonesia or Egypt? What would happen if the aurora went around the world? If you think that's impossible, think again. It could actually happen. In this video, we will learn about the aurora, its cause, how it occurs, how it happens on other planets, how it affects our lives, and what will happen if the aurora appears all over the world. But before we get into all of that, be sure to give this video a thumbs up and subscribe to our channel. And without further ado, let's get started. What is an aurora? Aurora, which is called the northern lights or southern lights when it appears in the south, is an atmospheric phenomenon that occurs in the high latitude regions of the Earth, where the sky is filled with colorful lights that dance and shimmer in the night sky. The stunning display of light is caused by the interaction between the charged particles from the Sun and the Earth's atmosphere. This solar wind collides with the Earth's magnetic field, causing the particles to be channeled towards the planet's poles. Once there, they interact with molecules of oxygen and nitrogen, exciting them and causing them to release energy in the form of light. The history of discovery of the aurora goes back thousands of years. Some of the earliest known records of aurora come from ancient Greek and Roman philosophers such as Aristotle and Pliny the Elder, who described the phenomenon as a fiery glow in the sky. During the Middle Ages, the aurora was often seen as a bad omen or a sign of impending doom. However, in more recent times, it has become a popular tourist attraction with people traveling to places like Alaska and Iceland to witness its beauty. As we know now, the aurora is caused by the interaction between the solar wind and the Earth's atmosphere. But it's not the only planet in the solar system that experiences this phenomenon. Jupiter and Saturn are known to have gigantic auroras that are hundreds of times larger than Earth's. These auroras are fueled by the powerful magnetic fields of the planets which interact with the solar wind to create a spectacular light show in their atmospheres. How does the aurora affect our lives? While the aurora is mostly a beautiful and harmless natural phenomenon, it can sometimes have a negative impact on our lives. During geomagnetic storms, the charged particles from the Sun can disrupt important systems on Earth, such as radio communication and navigation systems. For example, in 1859, a massive solar storm caused telegraph systems around the world to malfunction, sending sparks flying from the machines and even allowing messages to be sent without any keystrokes. Such disruptions can cause widespread blackouts and damage to infrastructure, leading to significant economic losses. Additionally, the aurora can pose a risk to astronauts and satellites in orbit as the bright lights can interfere with their vision and disrupt their operations. What is the aurora like in other planets? As we mentioned earlier, Jupiter and Saturn have the most impressive auroras in the solar system. Jupiter's aurora is over 1,000 times brighter than Earth's and is the largest of any planet. Saturn's aurora is also very bright and is known for its intricate and dynamic features. Neptune and Uranus, the ice giants, also have auroras that have been observed by Voyager and other spacecraft. These auroras are intermediate in complexity and brightness compared to those of Jupiter and Saturn. Although Mars and Venus do not have global magnetic fields, they still exhibit localized auroras that are generated by their atmospheric gases. These auroras are simpler and less intense than those of the gas giants and ice giants. Mercury, the smallest planet in the solar system, also has a magnetic field that interacts with the solar wind, creating auroras at its poles. These auroras are similar to those on Earth but are more faint and difficult to observe. Now that we understand what the aurora is and how it works, let's explore what would happen if the aurora appeared all over the world. What if the aurora appeared all over the world? If the aurora were to appear all over the world, it would undoubtedly be a spectacular sight to behold. People all over the planet would be able to witness the dancing lights in the sky, regardless of their location. However, this phenomenon would not be without its challenges. The bright lights and charged particles associated with the aurora could disrupt important systems such as power grids and telecommunications. Imagine sitting in your home in Indonesia or Egypt and looking up into the night sky. You would be able to see the northern lights dancing across the heavens, painting the darkness with vibrant hues of green, purple, and red. This once rare occurrence would now be a nightly spectacle visible from almost anywhere on Earth. But this breathtaking sight would come with some challenges. As the aurora extended further towards the equator, it would begin to disrupt important systems such as power grids and telecommunications. The disruption caused by the aurora could be catastrophic in areas that were not prepared for such an event. It would cause widespread blackouts and damage to infrastructure, leading to significant economic losses. Additionally, the sudden appearance of the aurora would cause mass confusion and panic among people who are not aware of the phenomenon. Many might mistake it for a sign of the apocalypse or some otherworldly event. This could lead to widespread panic and chaos as people try to make sense of what they are seeing. However, the appearance of the aurora all over the world would also present some unique opportunities. It would drive science tourism to new heights, with people traveling from all over the world to witness the spectacle. Governments and businesses would need to adapt quickly to the sudden surge in tourism and find ways to capitalize on it. Overall, while the appearance of the aurora all over the world would be a truly remarkable natural phenomenon, it would also present significant challenges and opportunities for humanity. It would require us to be prepared for the unexpected and to adapt quickly to the changes that come our way. But let's go back to the main question. What is a solar storm and how does it relate to the aurora? A solar storm is a disturbance in the sun's corona, the outermost layer of its atmosphere, which ejects plasma and electromagnetic radiation into space. These eruptions of plasma are known as coronal mass ejections, or CMEs, and they can travel at speeds of up to 6,180 kilometers per second. When these CMEs reach Earth, they interact with our planet's magnetic field, causing geomagnetic storms. Geomagnetic storms can cause widespread disruptions to important systems such as power grids and telecommunications. They can also pose risks to astronauts and satellites in orbit. During a geomagnetic storm, the charged particles from the sun can penetrate deep into the Earth's atmosphere, causing the aurora to extend further towards the equator. This means that people who live in areas that do not normally see the aurora, such as Indonesia and Egypt, may be able to witness this beautiful phenomenon. However, as mentioned earlier, this spectacle would come with its own set of challenges and risks. The impacts of the aurora on the Earth's atmosphere and systems are significant and far-reaching. One of the most notable impacts of the aurora is its ability to heat the upper atmosphere. The energy released by the aurora can heat the gas molecules in the upper atmosphere, which can lead to an increase in atmospheric density. This can affect the drag experienced by satellites in orbit, which can impact their stability and functionality. Additionally, the aurora can also stimulate the production of nitric oxide in the atmosphere. Nitric oxide is a highly reactive molecule that can contribute to the formation of clouds and haze in the lower atmosphere. This can have implications for air quality and visibility, particularly in areas where the aurora is most prevalent. Furthermore, the energy released by the aurora can also ionize the molecules in the upper atmosphere, creating a layer of electrically charged particles known as the ionosphere. This can affect the propagation of radio waves and other forms of electromagnetic radiation, which can impact communication and navigation systems. Overall, the impacts of the aurora on the Earth's atmosphere are complex and far-reaching, affecting everything from satellite stability to air quality and communication systems. Understanding these impacts is crucial for ensuring the safety and functionality of our technology and infrastructure in the face of this natural phenomenon. The study of the aurora and other space weather phenomena is becoming increasingly important in today's world. With the increasing reliance on technology and interconnected systems, it is crucial to understand and predict space weather in order to mitigate its potential impact. One way that scientists are working to improve our understanding of space weather is through the use of advanced computer models. These models allow scientists to simulate the behavior of the Sun and its interactions with the Earth's atmosphere and magnetic field. By improving these models, scientists can better predict the likelihood and severity of space weather events such as solar storms and their impact on our systems. Another area of research is the development of new instruments and observation techniques to monitor space weather. New instruments such as the Solar Dynamics Observatory and the Solar Terrestrial Relations Observatory are providing valuable data on the behavior of the Sun and its activity. By improving our ability to observe and monitor space weather, we can better prepare for and respond to these events. Additionally, scientists are also working to improve our understanding of the fundamental physics of space weather phenomena. This includes studying the behavior of plasma and electromagnetic fields and their interactions with the Earth's atmosphere and magnetic field. By improving our understanding of the underlying physics, we can develop more accurate models and prediction techniques. If you enjoyed this video and want to learn more about the wonders of our solar system, make sure to check out our other videos. We have covered topics such as black holes, neutron stars, and the search for extraterrestrial life. Thank you for watching, and I'll see you next time.